Hey guys, so I want to quick give you a couple more examples for partial fraction decomposition. Not because 5 points in your grade is going to make that huge of a difference, but because I think it's a super important topic that you're definitely going to use. This is one that I've had, I think I told you guys this before, I've had students come back and tell me that they were super grateful for learning this. So I have two different examples. So I have a repeated, excuse me, I have a repeated roots one. So we know we're going to need an x as a factor, right? But that's not repeated, so we're going to need an x in the bottom. The repeated roots, we start with first power and we keep writing it until we get up to the power that's in the problem, okay? And then linear, the linear denominator, we put a constant or degree 0 numerator, and then this is also linear. Even though this is technically not linear because it's squared, we're looking at just the inner part, the root itself. So all of these are considered linear, so we just put constant numerators. And then we want to get rid of the fractions. We don't like having a fraction. So if we multiply by the LCD, that's going to get rid of we got to distribute to everything. So this whole thing is going to go away. We're just left with x squared plus 1 on the left. And then the x will cancel out here. And then one of the x minus 1s will cancel out here. And then 2 of the x minus 1s will cancel out here. And then all of the x minus 1s will cancel out here. Okay, so there's two methods. We could multiply all this out and use the equate the coefficients method, but ugh, that doesn't sound fun. Let's try the convenient values method and see what we can get. So I want to pick, this should be true for all values of x. So if I pick a value of x, I should still have a statement that's true. So I want to pick a value of x that's going to make this convenient, meaning I'm going to choose x equals 1 because that's going to make all of this, all of this baloney go away. So if I plug in a 1 for every single x, I'm going to get 1 squared plus 1, right? And then this is going to go to 0, 1 minus 1. That whole thing goes to 0. 1 minus 1 here times whatever, that goes to 0. 1 minus 1 here, that goes to 0. So all I have left is d, again plugging in a 1. So this is sweet. D equals 2, okay? Well, I still need A, B, and C. So I'm going to choose another convenient value, x equals 0, and I'm going to be able to cancel out all of this stuff is going to go to 0. Because if I plug a 0 in there, I'm going to have 0 times baloney, I'm going to have 0 times baloney, I'm going to have 0 times d. So plugging in a 0 on the left, I get 1, right? And then I have a times 0 minus 1 cubed. Whoops. And then that's 0, 0, and 0. So I have 1 equals negative a, so a equals negative 1. And then you might be wondering, like, what do I do next? Because there's no other convenient value, and I still really don't feel like multiplying all of that out to equate the coefficients. So, again, we can pick any value of x to plug in. So I'm going to see what happens if so let me box these so I don't lose them. I'm going to see what happens if I like plug in a 2. Okay, so if I plug in a 2, 2 squared plus 1, plugging in a 2 here, I'm not going to show all this work. 2 minus 1 is 1, so we're good there, that's just a. Plugging in a 2 here, that's going to be 2b, and then again, 2 minus 1 is 1, so 2b. Plugging in a 2 here, 2 minus 1 is 1, so I have 2c. And then plugging in a 2 here, I have 2d, and you're like, that doesn't help. You have 4 variables, a, b, c, and d. But wait, I have d and I have a. So I know that a is negative 1, and I know that d is 2. So I can get 2b plus 2c. Let's see if I can do this. This is 3, so subtracting 3 from both sides, I get 2. Ooh, that's even nicer because I can divide everything by 2. Well, now I have 2 variables, but only one equation, so I probably want to try another convenient value and get another equation with b and c, and then go back to algebra 1. So I'm going to try -1. Why am I picking these numbers? Just because they're, like, I don't want to pick 5. 5 just, I don't want to deal with like 5 minus 1 and then cubed. So I was like, okay, 0 and 1 are super easy because those make that 0. 2 isn't ridiculous, but now I don't want to go to 3, so let me go into the negatives and see if this is going to work. So -1 squared plus 1. Okay, now I got to think. I might need to write this out because it's late and I'm tired. What is this? -1, so that's -2 to the third, that's -8. And you might be able to do this in fewer steps, which is fine. -1 minus 1, that's -2 squared, that's 4. That's -4b. I'm plugging in a -1 here. I'm going to get -2 times -1. So that's plus 2c and then minus d. And again, I already know a and d. Hope you guys can see this okay. I'm not really looking at the camera. So I'm going to plug in the a and the d. That's 8 minus 2, that's 6. So subtract that from both sides. Divide everything by 2. And then I could like maybe do something like this. And then sub in here. And then I have 3b equals 3, so b equals 1, and then I could sub back in here. If you need to slow this down, like, feel free. Okay, so there's your a, there your b, and your c, and then you're just going to rewrite this with the a, the b, and the c. I don't know how long, I'm not going to write that out because I don't know how long a video I can load on YouTube. I think it's 15 minutes and I am at 7.5, so let's do the second one. So you would just write it out with the a, the b, and the c in right here, okay? Okay, so this one doesn't have a repeated root, but it does have a quadratic root. So we know each of the factors is going to be the denominator of a fraction. This is a linear first degree, so we're going to put a constant on top, 1 degree lower, degree 0. This is quadratic, so we're going to put linear on top. And then same as before, we're going to multiply by the LCD. And then stuff's going to cancel. That's all going to go away. The x is going to go away. The x squared plus 3 is going to go away. This one I think is going to be easier. X minus 3 is all that's left over here. A times x squared plus 3, and then bx plus c times x. So I always prefer the convenient values method. It just is more convenient. The only thing that's going to make anything go to 0, though, is x equals 0. That's never 0. So x equals 0. I'm going to plug in. So 0 on this side, 0 in here, and then 0 times that whole parenthesis.